All right, so here's some more rate, time, and distance problems, okay? These are a little bit different. The solving this you're still going to set up a table, but you're always going to set up a table. But what you put into the table is going to vary sometimes. Now, what do we know here? See, watch this. This is what's different. Annie rides her bike the same distance that Jenny walks. Okay, Annie rides her bike. So we don't know. It's not saying that she's going 10 kilometers an hour. It says she's going 10 kilometers an hour faster than Jenny. If Annie takes 1 hour, Jenny takes 3 hours. So we actually know the time that they're traveling. Annie's 1, Jenny's 3. See, we actually know something different here. We know the time. What we don't know is the rate. Now, Jenny's we don't know anything about, so we call that X. But Annie, we know, is 10 kilometers faster, so 10 plus X. Distance is still going to be 1 times 10 plus X, which is just 10 plus X. And 3 times X is 3X. Remember, it says that they go the same distance. So 3X equals 10 plus X. Move the X over. 2X equals 10. X equals 5. Now remember, what does X represent here? X represents Jenny's rate. So Jenny rides at 5 kilometers per hour. Annie, of course, is 10 plus X. So that would be 15. So this problem was a little bit different, right? You still use the table, but you had different things that you were filling out in the table. This one's different as well. Don't hesitate to try yourself. Okay, we have Benji and Eric. What do we know? It says Benji begins walking towards Eric's house at 3 miles an hour. We know that. Eric leaves his house at the same time and walks towards Benji's house on the same path at 2 miles an hour. We know that. How long will it be before they meet if the distance between their houses is 4 miles? So this is different, folks. In the past, we've done problems where people are leaving from the same spot and going in the same direction. These two gentlemen here are leaving from different locations and they're walking towards each other. So this is a little bit different. Now they're leaving at the same time, okay? And they're going to meet. So if they leave at the same time, how much time is it going to take for them to meet? Well, the time is going to be the same. They leave at the same time, they walk towards each other. Doesn't mean that they're going at the same speed, but the amount of time that they are walking is going to be the same because they're going to meet someplace in between. Now this is where it's a little bit can be a little bit tricky. Maybe. Do we know how far Benji went? We don't, but we know that rate times times gives us distance. Same thing with Eric. So we know that Benji's distance was 3x, Eric's distance was 2x. They did not cover the same distance. They do not meet exactly in the middle because Benji's walking faster than Eric. All right. But remember, what was the distance between their houses? It was 4. So if they're going to meet in the middle between the two of them, they have covered 4 miles. Okay, one of them is going to cover more than the other. Benji's going to cover more because he's going faster. So this is the situation that we got. We get x equals 4/5 of an hour. But remember, 4/5 of an hour, don't ever tell anybody you're going to meet them in 4/5 of an hour. They think you're a jerk, right? 4/5 of an hour, what's 4/5 of 60 minutes? 4/5 times 60 is going to be 48 minutes. So the table is a good friend. but you just have to spend some time at the beginning setting up the table correctly, because you're going to have different information that goes into these things. All right. Here we go. We got a car. Actually, I think we got two cars. Car 1 leaves a house at 60. Another car leaves the same house, so car 2, at 50. Now, these guys are going in opposite directions. Now, they left at the same time. At what time will the cars be 330 miles apart? Well, they left at the same time, and they're driving continuously. They haven't gone the same distance, but they've been traveling for the same amount of time. So the time column is both going to be X. Car 1 has gone 60x, car 2 has gone 50x. And similar to the Benji problem, even though these guys are going opposite direction, the distance of car 1 plus the distance of car 2 has to equal 330. So you got combine like terms. Let me fix that. Divide by 110, and we get x equals 3 hours. Now, it says at what time. Remember, this means time on the clock. They left at 10 a.m., so 3 hours later would be 1 p.m. Okay?